And when you're ready. Okay, so this is a rotary evaporator, and we use it in industrial laboratories and in universities to evaporate volatile solvents. So when we make, as organic synthetic chemistry scientists, when we're making chemicals, pharmaceutical chemicals, or indeed any chemical, we need to evaporate the actual solvent that it's dissolved in order to get the purified crystalline solid and take it out of the actual solution to crystallize it. And to do that, we have to evaporate the solvent. And for that purpose, we use what's known as the rotary evaporator. Now, the rotary evaporator consists of a water bath, and we could put oil in it, so it will be an oil bath. Now, whether it's water or oil, water boils at 100 degrees Celsius at atmospheric pressure. Oil boils at something like 180 to 100 degrees Celsius, depending on the nature of the oil. And the solvent will have a boiling point much less than the actual the bath containing the oil or the water. So if the solvent, say, is ethanol, it has a boiling point of 70 degrees Celsius, which means at 70 degrees the solvent will boil off and it will leave the solid, which is the purified material that has been made. So we need to get rid of the solvent, which boils, say, at 70 degrees, which has a lower boiling point than the actual water, which boils at 100. So the solvent will boil off because it boils at 70 degrees and the water boils at 100. So when the water reaches 70 degrees, on its way to reaching 100 degrees before it boils, so when the water reaches 70 degrees, it will cause the solvent inside this round bottom flask to boil, because let's say it boils at 70 degrees. So when it boils off, you've got the phenomenon known as evaporation. So evaporation, it evaporates at 70 degrees Celsius and the liquid evaporates into a vapor or a gas. And the gas goes up through this condenser, which is cooler than the actual vapor, because the condenser has a temperature well below 70 degrees, let's say 25 degrees room temperature. So if it's water, it has a temperature roughly 20 degrees, 25 degrees, which is cooler than the vapor, which has a temperature above 70 degrees. Therefore, the vapor loses heat. Heat is energy that flows from body at a higher temperature to one at a lower temperature. So the heat is lost from the vapor to the cooling air or water. Right? So the air or water is cooler than the vapor, therefore the vapor loses heat, and when the vapor loses heat, it condenses into a liquid. So the vapor, which is, say in this case is ethanol, it condenses into this receiver flask. So you've got evaporation of the solvent, turns into a vapor, which is a gas. The vapor then cools because it loses heat to the water or the air, which is cooler than vapor, thereby condenses, and because of gravity, it falls as a liquid, which is received in this receiver flask. And then eventually what we have here in the rotary evaporator is, for example, a white crystalline solid, which is your pure chemical. It could be an anti-cancer agent, like when I was doing work on making anti-cancer drugs, or indeed any particular chemical. So that's how we use the rotary evaporator. And of course this machine, we can actually raise the temperature to whichever value we desire. Okay? Thank you.